Okay, so this is a quick overview of scatterplots, correlation, and causation. So what I'm going to do is I'm going to lay out just fundamentals of scatterplots, correlation, causation. That'll be the first video, and then I'll come back and kind of work 3 examples using 3 different options or platforms, and you can choose whichever platform you would like. Okay, so let's jump into this. So a scatterplot, right? Basically, it shows the relationship between 2 variables. Now, there may be no relationship. So let's say you got a graph, right? And let's call this variable x. Let's call this variable y, right? And so then you're going to have these they'll call them ordered pairs, and you're just going to have dots, right? So that's, and they're going to be, sometimes they'll be filled in, okay? All right. So, you know, so that's what it will look like. And you have some variable here. Let's call this time. And let's say this is, let's call this wages is the y-axis, right? So that's typical application, okay? So now, 3 types, okay? You have positive correlation. So as like in this example here, you had as weight increased, height also increased, okay? So that's a positive correlation, and we'll get into that when we do the next lecture or the next section on linear functions. We'll kind of apply these same principles, okay? Because we'll have some data, and we'll want to get to a correlation coefficient. So then you've got a negative relationship, right? So going down here from left to right. So as tiredness increases, the hours of sleep also decrease. That's what you call a negative correlation. And then you have a situation. So let's call this your first option, your second option, and then your third option. No relationship exists between the two variables, okay, or the 2 data sets. People can say that as well. You've got as shoe size increases, hours of sleep, right? So see how your data is kind of all over the place. We can't draw a line because we can't really say that, right? We can't say it's increasing. We can't really say it's decreasing. So the behavior of those pairs is not moving in a certain direction. So that's what we call no correlation. All right, so now let's talk about the correlation coefficient. And again, we'll eventually see how to find these correlation coefficients, but for today, we're just introducing the concept. Now, some people call this R. All right, now no, the range, let's say the range is from -1 to +1. So any value in between. Okay, so the sign indicates whether it's a positive or negative relationship. If R is less than 1, right, you got a negative relationship. So negative values, negative linear relationship. If R is greater than 1, okay, positive linear relationship. And if R is approximately 0, there is no linear relationship. And again, you can actually plot the data and see what's happening between these 2 variables. Now notice 2 variables, all right? So 2 variables. Can't do this with 3. At least not right now. All right, and then if R is approximately 1, they'll say something like there's a very strong linear relationship. So now, and it's the absolute value. So let's say we had R equals negative 1, right? You'll say that's a very strong negative linear relationship, okay? All right, so because remember, this means absolute value, right? And absolute value can only be, it could be 0 or positive, okay? All right, and so I'm going to jump ahead. We're going to come back and do these 3 examples. And let's talk about causation. All right, so now, just because 2 variables have a relationship doesn't mean that one variable is causing, all right, the change in the other variable. All right, so you always have to be careful when you move from correlation, which is just very casual, just looking at data, and we're seeing, okay, there is a relationship between 2 variables. All right, so let's break this down and use something that's practical. Let's take amount of time spent doing homework and grades. Okay. Now, or let's do this. Let's say attendance. Let's say attendance and final grade, right? Okay. So now typically what'll happen is, if a student is attending class, typically their grade's going to be a little bit higher. All right. So now that's just strictly going to class and your final grade. Okay. So let's break this down. Let's just draw this. So let's say as attendance, let's call that's our X value, right? And then we're gonna put and let's call this your numeric final grade. Okay, final grade. All right, and let's say we had something that kind of looked like that, right? And then we say, well, let's see if there's a correlation. So we say, okay, there's a positive. We'll say, well, that's a positive correlation. The more you go to class, the higher the likelihood that you're gonna have a higher grade in the class. But again, attendance, and you all know that just going to class is not going to guarantee that you're going to be successful. Okay, you got to actually go to class. You got to do work. You got to do a lot of different things to be successful. So we're going to stop there. So just note, a correlation is not the same thing as a causation. All right. So we'll stop here, and then I'll come back and do the 3 examples.